So now we're going to talk about something called a high arch or a supinated foot. So we have three reference X-ray radiographs from a lateral view. We can see a normal foot here with calcaneal pitch angle and the first metatarsal pitch angle relatively normal. And then if we look to our lower left, we can see more angulation of the calcaneus, so the calcaneal pitch angles more higher or more acute, and the same thing for the first metatarsal. And this would lead to a high arch foot, and is what we want to talk about right now. So essentially a high arch foot looks something like this. We have, from the posterior view, we can see that the hind foot is in slight amount of varus. So and we can see that the arch is quite prominent, and we can also see the toe, the big toe, from the posterior, which is something called the peekaboo sign, and it's even more acute in terms of the hind foot varus, and we can almost see two toes on the medial side on the right foot. So this is a kind of a classic supinated foot posture. From the front, we can clearly see the metatarsal with the heel showing up here from the front, and that's also a sign of varus, hindfoot varus. So these are both good indicators that this person has a high arch foot, in addition to the height of the arch that we would look from the medial side. So one of the theories is that the peroneal muscles are overactive, in particular the peroneus longus, remembering that the peroneus kind of is inserting on the first metatarsal and has the potential to plantar flex the first metatarsal. So one theory about over a high arch foot is the peroneal overdrive. The other arch raising muscle is the tibialis posterior. So in people with neurologic involvement, frequently the tibialis posterior can also be overly active, and that can help contribute to a high arch foot. So what are the consequences of a high arch foot? In this study by Cornwall and McPoyle, they had over 200 controls, and they basically measured arch height, and then did some various measurements of what would indicate stiffness of the foot or the range of motion of the foot with calipers. And here's a good example of one where they looked at foot width and people in high and low arch foot, weight bearing and non-weight bearing, and then noticed how much increased spread in the foot there would be when you were weight bearing versus non-weight bearing. They used that as a range of motion measurement. And so we can see here is some of their outcome data, which is going to make a real good point about the differences in foot posture and how that affects foot mobility. So we can see here this is their foot mobility, their change from weight bearing to non-weight bearing, essentially, and a variety of different foot measurements, and foot width, which is this middle one that we used as one example. But these other measurements have to do with falling and raising of the arch, and how much the toes move and things like this, right? And we can see that here's the bars represent different classifications of foot postures. So the black bar is a severely supinated foot, the gray here is a slightly supinated foot, and normal, and then a pronated foot, and then a very pronated foot, severely pronated, which means it's a flat foot. Well, we can see that on all the different measures, essentially a more supinated foot, which would be here, a more flat foot would be here, is that there's less mobility or less change in the scores as you go from a supinated foot to a flat foot. And so it's consistent that a supinated foot has less motion. And that essentially captures the main issue with people with supinated feet. Is we know that foot motion is important for shock absorption, especially during gait and functional activities. And when you have a supinated foot with less motion, your ability to shock absorb is compromised. And so a lot of the therapeutic strategies that are focused on people with supinated feet have to do with improving cushioning and adapting to the fact that they have less mobility.